So let's work through another example, and this is where you may want to pause the video, try it yourself, and come back and check your answer. So in this case, we are looking at 1 over 1 plus x on the interval from 0 to 1. We're going to do left and right sums with 5 sub-intervals. So our first step is really to figure out how wide is each rectangle going to be, and that's where we're going to find that delta x. Remember, that's the width of each rectangle. It's always b minus a divided by n. N is the number of rectangles. Remember, AB is your interval. So we're going to have 1 minus 0 divided by 5, which is 1/5. Okay, then it helps to have a picture of what the graph is going to look like. So if I graph 1 over 1 plus x, I've got another rational function here. It crosses the graph at 1, so think about this as a zoomed in picture. Crosses that y-axis is what I mean by that, at 1. So it looks something like this. And I'm splitting this interval from 0 to 1 into 5 pieces. I'm going to have 1/5. I'm going to use decimals because these are nice. Decimals, 0.2, 0.4, 0.6, 0.8, and then 1. So when I draw my left rectangles, remember I have to use the left-hand side always for the interval. So that first interval is from 0 to 0.2. That means this rectangle is going to touch at that left side of 0. And once again, you can see these are going to overestimate. So there are my rectangles. The left does not always overestimate. Sometimes it underestimates. It just depends on your picture. But here you can see those rectangles are going above that graph, which means each one's just going to give us an area that's a little bit larger than what it should be. So to find that left sum, it's going to be 1/5. That's how wide each rectangle is. Or you can call it 0.2 times the height. So the height of that first rectangle is going to depend on what the function is at 0. That's the left point. The second rectangle is going to depend on what the height of the function is at 0.2, which is the left point of that interval. The third rectangle is going to depend on the height at 0.4. The fourth is going to depend on the height at 0.6. And then the last is going to depend on the height at 0.8, since that's the left interval, the left endpoint for that interval. So we need to find what is f of 0, what is f of 0.2, what is f of 0.4. And I always try to use 4 decimal places. I think that's a good place to really start to get a good estimate there. So if I plug 0 into this function, and remember it's going in for the x, I'm going to get 1. If I plug in 0.2, I got 0.8333. If I plug in 0.4, I got 0.7143. If I plug in 0.6, I get 0.625. And if I plug in 0.8, I got 0.5556. I rounded everything into 4 decimal places. So now I just have to type that in. And my left sum is approximately 0.7456. So that would be the area between that curve and the x-axis, which would be this area in here. But remember, it's looking at each rectangle. So it's approximating that area under the curve. Now, if we were to use 10 rectangles, our area would be a little bit more accurate. But like I've said before, you can see how this is kind of a tedious process. But we're leading up to that fundamental theorem of calculus. So let's find the right sum. Our approach is going to be the same. I'm going to draw my picture. Going from 0 to 1. X-axis is still going to increment by 1/5 or 0.2. The picture looks the same, but the rectangles are going to look different because now we're using the right sum. So when I use that right, here's 0. If I use the right endpoint, the right endpoint of that first interval is 0.2. So that's where I'm making my rectangle. And you can see how these are going to underestimate. The right interval of the next section is at 0.4. Go up to the graph at 0.4, draw your rectangle. The right is at 0.6, go up, draw your rectangle. And so on. So if we want to find those rectangles, we've got to find the area for each one. So that first one is going to have a width of 1/5. To find the height, it depends on the function at 0.2. So I need to plug 0.2 into the function, and that will tell me that y value, which is the height. That second rectangle, we're going to use that right endpoint, 0.4, to find the height. The third one, we're going to use that 0.6 to find the height. The fourth one, 0.8. And then the last one, is going to use that 1. Okay, let's plug our numbers in. I plug in 0.2, I get 0.8333. 0.4 gives me 0.7143. 0.6 gives me 0.625. 0.8 gives me 0.5556. And then when we plug in 1, we get 0.5. So when I plug this into my calculator, I get about 0.6456. Okay, remember that underestimates that area under the curve. This one overestimates. So that actual area is going to be between those two values. Now, notice there's not as big of a difference between these two as there was in the last example. It really just depends on what the picture looks like, how steep is the curve, etc., how many rectangles you use. We used 5 rectangles in this case. The last example, we only used 4. If we were to use 10, those numbers would be even closer together. So that's how you look at left and right sums to estimate the area under the curve.